Hello everyone, welcome to Brain Blitz Audios. Today in this episode of NEET JEE-Main, we're going to be looking at previous year questions of physics asked in medical as well as engineering entrance exams in India. Today we're dealing with a topic of grade 12, and this is in fact the first chapter of physics in grade 12. The name of the chapter is Electric Charges and Fields. So this is the beginning of electrostatics, and so therefore this chapter is very important. It talks about, how to find charge and the formula for electric field for various cases and other topics related to it. So let's look at some questions of this chapter. Here's the first. A uniformly charged non-conducting disk with surface charge density 10 nanocoulomb per meter square having radius 3 centimeter. Then find the magnitude of electric field at a point on the perpendicular bisector at a distance of 2 centimeters from the origin of the disk. Okay, so now we have a disk with surface charge density as 10 nanocoulombs per meter square, and it has a radius of 3 centimeters. And you need to find the magnitude of electric field at a point 2 centimeters away from the center. So these are the quantities that we are going to work with. So this is basically electric field along the axis of a disk. So the formula here is E equals sigma divided by 2 epsilon naught times 1 minus x divided by under root of r square plus under root of r square plus x squared. Let's rub that part out. So here's the eraser rubbed back to the pen. So under root of r square plus x squared. Now, in order to simplify this calculations, we're going to multiply both the numerator and denominator by 2 pi. So sigma times 2 pi divided by 4 pi epsilon naught. And then inside the bracket, it's still the same, 1 minus x divided by r squared plus x squared. So over here, you have 1 by 4 pi epsilon naught. That is the electrostatic constant, K, which is 9 into 10 raised to 9. So the value of sigma is 10 into 10 raised to minus 9. And then the value of K is 9 into 10 raised to minus 9. 9 into 10 raised to 9, in fact, it's not minus 9. So then we will put in the value of 2 pi, that is 2 times 3.14, which is 6.28. And then inside the bracket, we'll put in the values of x and r. So in this case, x is 2 centimeters and r is 3 centimeters. So 3 squared plus 2 squared whole root. So 10 raised to minus 9 and 10 raised to 9, cancel each other out. So then you have 10 times 9, so that's 90 times 6.28. And then inside the bracket, it is 1 minus 2 divided by 9 plus 4. So now you need to multiply 6.28 with 90. So you can basically do 62.8 times 9. So 9 times 8 is 72. 2 times 9 is 18. 18 plus 7 is 25. 9, 6 are 54. 54 plus 2 is 56. So the electric field is equal to 565.2. And then inside the bracket, it is 1 minus 2 divided by under root of 13. So now you need to find out the value of under root of 13. So under root of 13 is approximately equal to 3.605 because, under root of 9 is 3 and under root of 16 is 4. So anywhere between those, you'll get under root of 13. So the exact value will be close to 3.605. So let's put in the value, so 565.2, and then root 13 minus 2 divided by root 13, so that is 3.605 minus 2 divided by 3.605. So the electric field will now be equal to 565.2 times 1.605 divided by, the denominator here is 3.605. So now this is the calculation that we need to do. So let's just, multiply the numerator as both as 4-digit numbers. So 5652 times 1605. 2 5s are 10, 5 5s are 25, plus 1 gives you 26, 6 5s are 30, 30 plus 2 is 32, 5 times 5 is 25, 25 plus 3 is 28. Then you have zeros here for the second, and then for 6, you'll have 2 times 6, that's 12, 5 times 6, that's 30, 30 plus 1 is 31, 6 times 6 is 36, 36 plus 3 is 39, and then 5 times 6 is 30, 30 plus 3 is 33, and then you have 5, 6, 5, 2, 000. Now you need to find out the value of this product. So units place is 0, tens place is 6, the hundreds place is 4, the thousands place is 11, so 1 goes there. 2 plus 1 is 3, plus 9 is 12, plus 5 is 17, 4, 6 gives you 10, 4, 5 gives you 9, so 9071460. Now you have 3 decimal points on one factor and 1 decimal point on the other factor. So when you multiply that, you'll get 4 decimal points. So when you take 4 decimal points backwards, you will get the product on the numerator as 907.15, because approximating 46215, and then divided by 3.605. So now we need to divide. What we need to do is we need to divide 907,150 divided by 3605. So doing that, we'll get the answer to what is the electric field in this question. So E is equal to 907,150 divided by, 3605. So 9071 will be close to 3605 times 2. So 3605 times 2, that's 10. And then 12. 6 plus 1 gives you 7. So 7210. 1 minus 0 is 1. 7 minus 1 is 6. 10 minus 2 is 8. 8 minus 7 is 1. So 18615 is our next step. So when you take 3605 times 5, 25, and then 6 5s are 30, 3 5s are 15, plus 3 is 18. So that's the closest. So 25, and then 18025. So then 5 minus 5 is 0. 11 minus 2 is 9. And then 5 minus 0 is 5. And then 8 and 0 get cancelled out completely. Then you have an extra 0, so 5900. So 5900 is close enough to 3605. So 3605, when you do that, you'll get some remainder, but that is inconsequential because you get the electric field as approximately equal to 251 newtons per coulomb. So this is the correct answer that we are looking for, because we just need to find the approximate value here. Because our options, all of them are whole numbers, they do not have decimals or any other stuff like that. So the closest value should do. So option A, 251 newtons per coulomb, is what we get when we do this division. So option A is the correct option for this question asked in 2018. Next question, again from 2018. A long, solid, non-conducting cylinder of radius r is charged such that the volume charge density is proportional to r, where r is the distance from the axis. The electric field E at a distance r, which is smaller than the radius, will depend on that distance r as whether E is proportional to r squared, inversely proportional to r, or inversely proportional to r squared. So, according to the question, the volume charge density is proportional to r. So the volume charge density is rho. Rho is proportional to r, so that means you can write rho as equal to k times r. Whatever k is, it does not matter. Now, since the change in charge can be expressed in terms of density times volume, we can use this equation for density and then for volume, and then find out the value for delta Q. So the value for delta Q will be 2 kr times 2p times rdr times L, because it's volume. So 2 pi rl dr will give you the value of dq. So now we know the value of dq, we can straight away go on to use the Gauss Law. So if you don't know what the Gauss Law is, you can go to our video, the mind map on this chapter, Electric Charges and Fields, which talks about Gauss Law. So therefore you can go there and you can refer to it if you want to. So you can hit the link for the playlist in the description down below. So moving on, Gauss Law. What does Gauss Law states? The Gauss Law states that E dot ds equals Q enclosed divided by epsilon naught. So here the electric field is E, and we need to find out, we need to know what is ds, so that's the area. So in this case, the surface area is 2 pi rl because it's a cylinder. And then you have integration in here because we need to find the charge and not the change of charge. So integration from 0 to r, kr times 2 pi rl times dr divided by epsilon naught. So you have 2 pi rl on both sides, so you can cancel them out. So the electric field E equals into k times integral 0 to r rdr divided by epsilon naught. So that is k r squared divided by 2 epsilon naught. So the equation's values does not matter because we now know what is the relation between the electric field and the radius, the distance. So E is proportional to r squared. This is the correct relation. And if you look at our options, you can see that option B is the correct option. E, that is the electric field, is proportional to r squared when the volume charge density is proportional to r. Next question. An early model for an atom considered it to have a positively charged point nucleus of charge ZE, surrounded by a uniform density of negative charge up to a radius capital R. The atom as a whole is neutral, so you need to find the electric field at a distance r from the nucleus. So what we know is that the Q inside the nucleus, the charge inside the nucleus, is Z times E. And since the atom is neutral and it contains a uniform negative charge density up to the radius, you can write Q negative as equal to minus Q nucleus, which is equal to minus of ZE. So whatever is inside the nucleus will be equal to whatever is outside the nucleus in terms of charge. So that's how the atom is neutral. Now, we need to find out the negative charge density and then find out the electric field at a distance r from the nucleus. So how do we do that? Well, the negative charge density here in this sphere of an atom is rho, that is the volume charge density. So that is Q by V, charge divided by volume. So therefore you can write the charge as minus ZE, since that's the entire negative charge, and then you have 4 by 3 times pi r squared. That's, pi r cubed, which is the volume of the sphere. So you get minus 3 by 4 times ZE divided by pi r cubed. So this is the value of the negative charge density. So what we do is we consider a Gaussian surface with radius small r, because that's what we need to find out. So we just take a Gaussian surface like this with the radius small r, and we apply Gauss theorem. So by Gauss theorem, you will get electric field with respect to r times the change in volume, change in surface area, that is 4 pi r squared, that is equal to Q divided by epsilon naught. And in order to find out the charge, this is basically charged enclosed. So that means it contains both the positive as well as the negative charge. So the positive charge is ZE, and the negative charge here is basically the volume of the sphere that is enclosed within the Gaussian surface times the negative charge density. So 4 by 3 pi r cubed times rho. So that is ZE plus 4 by 3 pi r cubed times rho in this case is minus 3 by 4 times ZE divided by pi times capital R cubed. So 4 gets cancelled, 3 gets cancelled, pi gets cancelled, and you'll get and over here it's basically small r because you are dealing with small r, so therefore don't write capital R there. So you get the charge as ZE minus ZE divided by ZE times R cubed, that is a small r cubed divided by capital R cubed. So what are we going to do? We'll just now apply this for the electric field. So the electric field is Q by 4 pi epsilon naught r squared. So this is the general formula for the electric field. We're going to apply that here, the value of the charge. So that is ZE minus ZE times R cubed by capital R cubed, whole divided by 4 pi epsilon naught r squared. So what we can do is we can take ZE by 4 pi epsilon naught common out. So you will get 1 by r squared, small r squared, minus small r cubed divided by small r squared gives you small r in the numerator, and then in the denominator there's always capital R cubed. So this formula that we get is the actual formula of the electric field that we need to find out for a radius small r. So therefore option A is the correct option for this question. For option B to occur, you need to have R cubed in that formula, which is incorrect. Again, in option C, you need to have the signs changed, which is incorrect. And in option D, again, the signs change, so that makes it incorrect as well. So option A is the correct option for this question, which, by the way, is asked in 2017. Let's look at another question of 2017. In a certain region of space, electric field is along the z direction throughout. The magnitude of electric field is, however, not constant, but increases uniformly along the positive z direction at the rate of 10 raised to 5 Newton per Coulomb meter. You need to find out the force experienced by the system having a total dipole moment equal to 10 raised to minus 7 Coulomb meter in the negative z direction. So what we're going to do is we're going to consider an electric dipole with a charge of minus q at a point named A and a positive charge at, say, a point B. And this is placed along the z-axis such that the dipole moment is along minus z-axis, the negative z-axis. So it would be something like this. You have a plus here, plus q here, and then you have a minus q here. So basically the net dipole moment goes down. This is minus z, this is plus z, that's x, that's y, and all the other directions there. So we know that the dipole moment is equal to 10 raised to minus 7 Coulomb meter along the negative z-axis. So therefore, the dipole moment in minus z is equal to, dipole moment in z is equal to minus, 10 raised to 7 Coulomb meter. Minus 10 raised to minus 7 Coulomb meter. So, so this is based on the positive z-axis. So we need to find out the electric field. We need to know what is the electric field along the z-axis. So if you look at the question, it says that the magnitude of electric field is not constant, but it increases uniformly along the positive z direction at the rate of 10 raised to 5 Newton per Coulomb meter. So basically what it says is that dE by dZ is equal to 10 raised to 5 Newton per Coulomb meter. So how are we going to write this? So force can be written down as Q times energy. So here energy is in terms of dE, so therefore that's Q times dE, which is Q into dZ times dE by dZ. So we know that Q charge times the displacement gives you the dipole moment, so that's P times dE by dZ. So we know the dipole moment, we know the we know the change in electric field. So now we just need to apply it. So what we need to remember is that the force is experienced in negative z direction. So we need to change our values accordingly. So over here, F is minus of P times minus of dE by dZ. So the value of P is minus 10 raised to minus 7, so that becomes 10 raised to minus 7. And then dE by dZ was 10 raised to 5, so we need to write it as minus of 10 raised to 5. So, well, you have minus 1 over here, and then you have 10 raised to minus 7 plus 5. So therefore, you get minus 10 raised to minus 2 newtons as the correct answer for this question. And if you look at our following options, you can see that option A is the correct option. So here, since we're taking it along the z, since the force is expressed along the z-axis, we need to put a minus in order to understand that the force is acting in the negative z direction in reality. So therefore, option A is correct instead of options B, C, and D, because C and D have numerical values different and B has opposite direction, so that is incorrect. Let's look at the final question of this episode. Two charged spheres are separated by a distance d. They exert some force on each other. If they are immersed in a liquid of dielectric constant 2, then what is the force exerted if all other conditions are the same? So what happens is that the force exerted is not in free space, it's in a liquid of dielectric constant 2. So that's the only change that we need to apply here. So the distance is d as given in the question. Dielectric constant is 2. So therefore, we'll just apply force between two charged spheres as 1 by 4 pi epsilon naught q1 q2 divided by r squared, because here, well, r is the same, two charged spheres. Now this is the formula for free space. So what happens is that for a dielectric, so for a dielectric liquid, the value f dash will actually be 1 by 4 pi epsilon naught times k, which is the dielectric constant. And then you will have q1, q2 divided by r squared, because all the other quantities are the same. So basically, f dash is equal to f divided by k, so the original force divided by k. And since the value of k is 2, the value of f dash is f by 2. So if a dielectric constant of 2 is acting on two charged spheres in this question, then the force is decreased by half. So therefore, if you look at our options, you can see that option A is the correct option. So that concludes this episode of NEET JEE-Main. If you want to access more of our videos, you can subscribe to our channel, which is Brain Blitz Audios. We also have videos on other chapters in NEET preparation, so you can access that in the playlist given down below. And also, if you want to access more of our videos regarding the chapter in mind maps, then you can access the playlist link for mind maps in the description box down below. So until the next webisode, take care, stay safe, bye bye for now.